Welcome to the Explainer. Today, we're going to put on our hard hats and take a tour of a digital factory. No, this place doesn't make cars or phones. It processes information on a scale that's almost impossible to imagine. And you know what? It's the blueprint for how pretty much all big data works today.
All right, let's kick things off with a question that sounds, well, impossible. How would you count every single word on the entire internet? I mean, seriously, think about that. If you tried to get just one computer to read all those billions and billions of pages, it would take centuries, literally. So how does a company like Google actually do it?
And that right there is the fundamental problem of what we call the big data era. We're drowning in information. It's coming in way too fast. And the old way of doing things, just using one big, powerful computer, it just doesn't work anymore. It broke. The whole assembly line just got jammed.
The solution, it turns out, was this brilliantly simple idea called MapReduce. The whole insight was, hey, why try to build one giant, impossibly powerful supercomputer? Instead, let's build a massive data factory. A factory where thousands of totally normal, everyday computers all work together on one single, perfectly coordinated assembly line.
Okay, so what does this whole digital assembly line actually look like? Let's go ahead and step right onto the factory floor. We're going to follow one piece of data from the very beginning all the way to the end.
So here it is, the core process. It all starts with step 1, input splitting. Imagine you have a giant library of books. That's your data. This step just tears it all up into individual pages. Then step 2 is the map phase. Think of thousands of little worker computers. Each one grabs a single page and just makes a simple list of every word it sees and puts a 1 next to it, like the 1, river 1, the 1. Easy. Next up, shuffle and sort. This is like a giant, automatic sorting machine. It takes all those little lists and groups all the identical words together. So all the 1s from all the different workers, they all end up in the same pile. And finally, reduce. A new set of workers comes in, looks at each pile, and just adds up the 1s to get a final count for each word. It's just a beautiful, elegant division of labor.
But wait a minute, having thousands of little robot workers running around sounds like total chaos, right? You absolutely need a foreman, a task manager who's calling all the shots, deciding who does what, and making sure the entire factory is running like a well-oiled machine.
And this manager, it has number one golden rule: data locality. Just think about it for a second. Moving petabytes of data across a network, that's like trying to move a whole mountain of bricks with just one tiny little pickup truck. It is painfully slow. So the manager does the smart thing. It sends the small computer program, the little worker drone, to the machine where that mountain of data already is. You don't haul the raw materials all the way across town to the factory. You bring the factory right to the raw materials. It's a game changer.
Now, a huge part of this manager's job is just scheduling. You've got two main strategies here. On one side, you've got first come, first served. It's simple, seems fair enough, but the problem is if one really big, long job gets in line, it can create a total traffic jam for all the smaller, quicker jobs waiting behind it. Then on the other side, you have the fair scheduler. This one's a lot smarter. It's more like an expert traffic controller, constantly balancing the load, making sure those small, quick jobs can always find a lane to zip right through. And believe me, making the right choice here is the difference between an efficient factory and total gridlock.
Okay, let's be realistic. In a factory that's running on thousands and thousands of cheap computers, stuff is going to break. It's just a fact. Wires get unplugged, hard drives die, sometimes the machines just give up. So what happens when one of those workers on our digital assembly line just stops cold? And this is maybe one of the most brilliant parts of the whole design. For MapReduce, failures aren't some rare exception. They are the absolute expectation. The entire system was built from the ground up, assuming that things would go wrong. It knows machines will overheat, networks will get clogged, and tasks will crash. In this world, failure is totally normal. And that's its superpower, automatic fault tolerance. That manager, the foreman, is constantly watching every single worker. If it sees one of them fail, it doesn't panic, it doesn't stop the whole assembly line, it just calmly takes that worker's little piece of the job and hands it off to another machine that's ready to go. The job just keeps on chugging along, completely uninterrupted. It's amazing.
All right, so we've seen how the factory works on the inside. Now let's kind of zoom out a bit and look at the bigger picture, its legacy. Because this simple blueprint, well, it fundamentally changed the entire world of technology. Before MapReduce came along, if you wanted to process a massive amount of data, you needed one thing: a single, ridiculously expensive supercomputer. MapReduce just completely changed the game. You could say it democratized big data. All of a sudden, you could get that same level of power just by linking together thousands of cheap, commodity, off-the-shelf servers. It was scalable, it was resilient to failure, and for the very first time, it was actually affordable.
But, this factory design wasn't perfect. It definitely had its limits. Because it was so obsessed with safety and not losing any work, it was constantly writing its progress down to the hard drive. Now, that made it super reliable, but it also made it kind of slow. And that's a huge problem when you need answers right now in real time, or when you're trying to process a never-ending river of data, like a Twitter feed. This factory was built for huge batches of work, not for speed.
You have to think of MapReduce as that essential first step. It was like the Model T of big data. Not the fastest car, not the prettiest, but it proved the whole assembly line concept actually worked. Newer, much faster frameworks like Apache Spark, they learned from MapReduce's design. They kept the core ideas, but they figured out how to do a lot more of the work in the computer's memory instead of on the slow hard drive, and that gave them just incredible speed.
So the real takeaway here isn't just about one specific technology. It's about the fundamental principles that MapReduce proved to the world. Principles like divide huge problems into tiny little ones, move your programs to where your data lives, and always plan for failure. These ideas are the blueprints for every single modern data factory out there today. So understanding MapReduce, it doesn't just teach you about the past, it gives you the keys to understanding the future. Which leaves us with one big question. If this was the first generation, what are the next generation of data factories going to build?